Welcome back, everybody. So this week I have my good friend from Annex Paint, Greg Saundrs. I know you guys have heard a lot about him. He is kind of one of the originators of Test Don't Guess, I would say. He's the one that kind of a guy that pushed me to do this whole channel. So welcome aboard, Greg. Glad to have you.
Hey, thanks a lot. It's great to be.
Yeah. What we want to talk about today is kind of how to get started as a new finisher. We'll probably go through equipment setup, sanding, a whole lot of stuff. Both of us get a ton of questions, and Greg is really big on education for the up and coming generation. So he wanted to, have an opportunity to come on, and we're going to talk to new finishers, because most of my channel is really geared more towards the seasoned professional, and a lot of this stuff goes on over a lot of your guys' heads. So we're going to kind of do a start from the basics kind of deal today.
Yeah, and I want to say, just to say to the community, I love the calls. I love talking to people. I love helping people get going, and I get a lot of calls, and it's always fun to get someone over the hurdles of what to do and how to do it. Finishing is not rocket science. There is technology to it, and it's understandable. And once you get into it, actually, the reason I started my blog was because there were so many different things that manufacturers would say, and no one would tell you the truth. So I started telling people the truth about what coating did what, and it caught on. So anyway, I enjoy helping new people get into business. So here we go.
Yeah, absolutely. And your blog was the reason that I ended up finding CIC in the whole Centurion line. So that's a pretty cool story.
Yeah. Funny story about that blog. For all the marketing that you do as a salesperson, that's a free WordPress blog, and it's brought me more business and kept me more busy than anything else.
Awesome. All right, so let's just start. I think a good place to start for beginners is kind of like the rundown on what kind of coatings are out there. Just kind of do a quick snippet of like solvent base. And then most of the people that are watching my channel are going to be probably geared more towards the water-based technologies. But I think it's good to understand kind of, where you start with solvents or nitro, and then kind of move up from there. Good, better, best.
Good. So for many years, there's been just lacquer, regular nitrocellulose lacquer. Nitrocellulose lacquer is the simplest, the easiest. It's the easiest to spray. It looks great. It goes on very well. It's not very waterproof, so that's the bottom line. And that's what you see a lot of furniture finish with, is just regular nitrocellulose lacquer. It will yellow over time, and it is not good for kitchens and baths because of that, because water will damage it. Moving up from there are pre-catalyzed lacquers, and pre-catalyzed lacquer started in the 30s and 40s when kitchens started getting more and more finished, and they needed something to be a little bit more durable in a kitchen. So it smells worse, it's harder, and it's actually probably the industry standard for what goes into the normal kitchen. Above that is what's known as a conversion varnish. A conversion varnish is a slightly different chemistry. It doesn't yellow as much. It's a catalyzed product, so you have to add a catalyst to it. Actually, 2% catalyst is generally what goes into conversion varnish. It's harder, better, tougher. It's also more difficult to spray, a little bit more difficult to spray. It's more difficult to touch up. Beyond that is a polyurethane, and polyurethanes are automotive finish. They go on, you can have automotive finishes on your tabletops, on your furniture. It's a bit of an overkill to have the finish as hard as your dinner table finished as well as your car top, but many times people do it. It's more expensive. It's a 2-component product, so you have to mix part A and part B. It dries very hard, and that's kind of the gamut. Then we hit the WaterBased, and WaterBased almost has the same stepping ladder of echelons of hardness. There are water-based urethanes, there's water-based conversion varnishes, and there's just regular water-based lacquers. How's that?
And on the water-based side, you kind of have like kind of 3 categories and then some hybrids. So you have like an acrylic, like oil modifieds, and then you have polyurethanes, and then you have like the mix of all those kind of in between. And companies, I feel like, have done a poor job in explaining that, because most of it has been trying to label it so that a solvent finisher would go, oh, this is the same as pre-cat, this is the same as conversion varnish, this is the same as that. So wildly confusing in water-based, and sometimes it's hard to know exactly what you are shooting at times.
Exactly. And not only that, the chemistry divisions in solvent-based are pretty well defined. Water-based, however, is all over the charts, because a water-based chemist can do things one way, whereas someone else does it completely differently, and they all call it a water-based lacquer.
Right. And to kind of further what you're talking about there, so if you guys think about it this way, solvent-based materials have more of mathematical ratios to them. So if you add XYZ of this, then there has to be XYZ of that. With water-based, that's not the case. You could put a whole bunch of this, a whole bunch of that. It could work, it might not work. And then there's all the things that we've run into that we've found that, sometimes crosslinkers and hardeners work in products that we didn't think they would. So it's sort of a technology that's constantly evolving. However, we do have, I think this is a big confusion in the world of polyurethanes. And I know that we've had dinner and hung out with Miles Woolley from CIC, and we talked about that there are true 2-component water-based urethanes. And then you have this mono bicomponent. So with the true 2Ks, you actually have to add a catalyst to them for them to dry and perform properly.
Pretty much true. Pretty much true. And again, and with water-based, though, there's variations, which
Sure.
Comes back to your theme. And I don't want to go sideways on what you're saying there, but comes back to the theme of test, don't guess. Because if you think something will work in one product because it worked in another product, it's not necessarily true.
Right. Exactly. Amen to that.
A quick story on that, and there's always room for experiment too, and you're a great pioneer of that, because you've done things that I never thought of, and it worked, but you experimented with it and on the side, but years ago I found that you could use a regular lacquer retarder in the CIC conversion coating, and that was really cool. And the basic product of that was glycol ether. So that was really interesting. I found I was in up in the high desert in a shop, and it was 110 degrees, and even the water base was drying so quick that it was orange peeling all over the place. And we had a little bit of lacquer retarder, and we said, well, what the heck? Let's try it. Worst case scenario, we'll have to strip it and redo it. So we tried it, it worked, and that was an amazing find. Months later, I tried a lacquer retarder in the conversion varnish again, and it foamed up into this gelatinous goo, and it was like I was supposed to be the hero, and then this job just turned to mess because I added this lacquer retarder to my water-based product. And it turns out not all retarders are made the same. So again, test, don't guess.
Yeah, absolutely. And so So what we would say to you as a new finisher when you're getting products and you're trying things to, um, I always recommend guys, doing a small project like a bathroom vanity or something, that if something goes wrong, you're talking about 5, 6 doors instead of a giant 50-piece kitchen that you have to redo. Or even that, what I really like to do is, take scraps and, you can go find a local cabinet shop or a designer that has old doors, that you can try these various finishes on and try them in different combinations, and kind of figure out what works, what equipment works with it, because that's one of the biggest issues with water-based, is you have such a variation with these coatings like we talked about, that various equipment can work and some of it doesn't work, unfortunately. So I think that's important to know. I think overall, if you're getting into finishing, and you're doing water-based per se, I think that we've kind of alluded that regular cup guns and airless is probably going to give you the least amount of trouble over across the board. Now, I'm not saying that that's 100% accurate, but I think that for most coatings that we've looked at and tested on my channel, airless and just a regular HVLP or conventional cup gun seems to bring about the least amount of issues. Now, in saying that, when you get to some of these high viscosity water bases, if you want to shoot out of a conventional or an HVLP airless, and I'm talking about Harbor Freight, I'm talking about inexpensive guns, you do have to reduce the material for some of these. Some of them you don't, some of them you do. What's kind of been your experience on that?
Pretty much that. And in the last few years, we found that airless is actually a far superior, with fine finish tip and some other things. The airless actually does a better job. And with water-based, you don't really want to introduce a whole lot of air. With cup guns, they introduce air. So the airless is coming out to be the far superior way, but a cup gun will work. And on that note, one of the questions I always get asked is, well, what tip should I use and how much pressure should I use, and what gun should I use? Should I use my Fuji 4-stage turbine? And the question is and the answer is always, well, what gets it out of the gun and onto the substrate the best, and that's where I found even within a brand, some guns perform a little bit differently. So the subject of finishing is a moving target. You have the viscosity of the material, the air pressure, the size of the needle, the amount of pressure if you're using conventional or cup gun, and things like that. So it's never even when you know the material, you have to set up your gun each time, because humidity and temperature have a play in things. So recommending one tip size and one gun for any product, isn't the way to go. It's more, you have to get out there and play with it, turn it up, turn it down, see what goes on best, see what goes on the smoothest, etc.
Yeah, absolutely. And for guys that haven't watched this video, I did a video last week with Russell Cragelis, and he's a really exceptional finisher out on Instagram. And that's one of the things that we talked about, the guys that are using air-assisted airless, and kind of the problem with air-assisted and airless and water-based is you have to have a large variety of tips that are very expensive in order to determine what works best with some of these coatings. Now, solvent, on the other hand, pretty much all this equipment that we're talking about, it just works.
Right.
90% of the time. You might have a 10% where, something, but by and large, most of your solvent coatings, like, it's just not as difficult to determine what works. You can use a turbine, you can use HVLP, you can use air assisted airless, and they're all, slightly different with the way you set them, but it's a lot easier to get there than it is with a water base. And so guys are always asking me, getting back to what they're like, what pressure do you shoot out? What tip do you shoot out? Well, what's the substrate? How much absorption rate am I going to have? All those play into my decisions when I am, shooting. So it's hard to say, and it's an experience thing. And I'll just give some generals here to get people started. But if you're doing the turbine systems, generally a 1.3, a 1.5, and a 1.8 is going to do the jobs for you, depending on products and that sort of thing. Sort of the same way with your cup guns, 1.3 to 1.8, or any variation in between. Some of them like 1.4, 1.5. Don't get mixed up too much in the semantics of that. That's going to come later as you start dialing in. You see the slight minutia and the differences. And then as far as airless is concerned, if you're new to it, I would recommend don't go any bigger than a 308 fine finish tip. You might even want to try a 408. Tritech does have those. A lot of guys try the 208s, but the issue with the 208s is if you're not really good at spraying, the problem is you have such a small overlap, and a lot of guys load on too much material, and they have a lot of issues with bridging and runs and things like that. So I would start with a 308, and then you can expand from there to a 310 and even a 312, for certain coatings.
Yeah, and you might also expand what's the differences between those the size of that tip, because you also have the fan pattern in there.
Oh yeah, so the first number is your fan pattern. So at 3 inches, if you're, I think, 6 inches away, that's a 6-inch fan pattern. If it's a 4, then it would be 8 inches. If it's a 2, it would be 4 inches. So you double the front number, and then the next number represents the size of the orifice. So if it's an 08, that's an 8 thousandths. If it's a 10, that's a 10 thousandths. And then a 12 would be a 12 thousandths. And that also translates into air assisted airless, where you can go down as small as an 07 and as large as, I think it's like 15 or 17. And it's the same way with airless. And it's just a difference between the way that the tips are manufactured, but they still are in orifice. Now, if you've seen, everybody knows Kremlin, they use a different system. So like an 06 is an 11 thousandths.
I was thinking of Kremlin, and I thought, well, I probably won't go there just to keep it from being confusing. But yes, exactly. So there are the variations. That's yeah.